Humans are curious and simply want to know more. Thanks to this innate desire, modern humans can build on the accumulated knowledge of generations before us to arrive at where we are now. One of the biggest questions we've been attempting to find answers to is if we are alone in the universe's intelligent life forms. However, one obstacle to learning about space is distance, as our technology limits where we can reach. But there is a solution around the corner that will make deep space travel way faster. The discovery required the best minds, including Elon Musk and NASA. What is this method of travel and how does it work? In this video, we bring you how Elon Musk and NASA finally reveal the light-speed engine that defies the laws of physics. Elon Musk is not afraid to attempt what nobody has ever dared to do. He is used to doing big things that you would expect him to try to set up a colony on Mars. Musk believes the best way to help humanity is to set up some humans to live on Mars permanently and populate the place. His fear is that an errant asteroid could hit the planet and wipe out every breathing thing on it. But with a branch of the human race planted on the red planet, we would be able to survive. This is no mean feat even for the world's richest man. Mars is a brutal place to try to set up a permanent camp. You can't even breathe the air or be exposed to the radiation. However, Musk will work his way through all those issues to get to his goal. But one of the biggest obstacles is distance. The distance between the Earth and Mars is not constant, as the two planets orbit the Sun at different elliptical paths from the Sun. But the shortest distance between the two planets is 33.9 million miles, or 54.6 million kilometers. That doesn't even happen often, as you have to wait 26 months for this cycle to repeat. Building a spaceship that can cover that huge distance is a huge problem because you somehow have to carry enough fuel for the long trip, which might last 5 months. And that is not even the biggest problem. What gives Musk sleepless nights is how to protect his colonizers during the months-long journey. A high level of protection is needed because traveling through space is nothing like moving from city A to city B on Earth. Deep space is full of something that could kill you: radiation. If the spaceship is not protected enough, radiation will simply kill off or seriously weaken the prospective Mars settlers. That would not augur well with his plans for a self-sustaining colony. In addition to that, spending so much time in a low-gravity environment is a bad idea. It wrecks the muscles and affects the bones. So basically, all the travelers will arrive on Mars unable to lift an arm or leg. That is not going to work for Musk. Even the thought of spending months in the middle of nowhere where you can't even call for urgent help is scary. And things may go wrong with the spaceship itself. Also, what if one of the colonizers changes their mind about living on Mars? They will probably have to wait for the next window of opportunity before setting out back for the Earth. All this is against the backdrop of Musk's plan to transport 1 million volunteers in a short time. That would be preceded by tons of cargo going ahead of the colonizers to prepare the planet for permanent habitation. All these issues can be solved by a single solution: fast travel time. In fact, with a very fast travel time, humans can go even further than Musk is targeting. Uranus, for instance, is some 1.6 billion miles or 2.6 billion kilometers away from us, and at that distance, even Musk will not dare. Beyond our solar system, a speedy means of transportation can help us reach some of the stars you see in the sky. Those stars are trillions of miles away. They are so far that scientists had to come up with a new way of measuring distances: light years. The Proxima Centauri, for instance, is 4.24 light years away. A light year is equivalent to 5.88 trillion miles or 9.46 trillion kilometers, and this is the closest star to us. Scientists also love to investigate exoplanets, or planets that are outside the solar system. They are hard to detect, but they're interesting because they may hold the answer to the question of whether we're alone in this universe or not. One of the fastest ways to travel is to travel at the speed of light. If humans can achieve that, traveling through space will become so easy. Musk's Mars volunteers will only spend minutes in transit and they will be in their new home. However, most speed of light travel has been confined to the magical world of sci-fi movies, so many people wonder if it is possible. Well, NASA is known for solving problems that you didn't even know you had. One of its engineers, David Burns, has been working on a solution in his spare time. he has now produced an engine concept that he says could theoretically accelerate to 99% of the speed of light, all without using propellant. He's posted it to the NASA Technical Report server under the heading Helical Engine, and on paper, it works by exploiting the way mass can change at relativistic speeds, those close to the speed of light in a vacuum. It has not yet been reviewed by an expert. Burns' paper caused buzz approaching levels not seen since the early days of the EM drive, and yes, even some headlines claiming the engine could violate the laws of physics. But who cares about the laws of physics if the outcome is what we need? So how does the helical engine work? As a thought experiment to explain his concept, Burns describes a box with a weight inside, threaded on a line with a spring at each end, bouncing the weight back and forth. In a vacuum such as space, the effect of this would be to wiggle the entire box, with the weight seeming to stand still, like a GIF stabilized around the weight. Overall, the box would stay wiggling in the same spot, but if the mass of the weight were to increase in only one direction, it would generate a greater push in that direction and therefore thrust. According to the conservation of momentum principle, in which the momentum of a system remains constant in the absence of any external forces, this should not be completely possible. But there's a special relativity loophole. According to special relativity, objects gain mass as they approach light speed. So if you replace the weight with ions and the box with a loop, you can theoretically have the ions moving faster at one end of the loop and slower at the other. But Burns' drive isn't a single closed loop. It's helical, like a stretched out spring, hence helical engine. The engine accelerates ions confined in a loop to moderate relativistic speeds, and then it varies their velocity to make slight changes to their mass. The engine then moves ions back and forth along the direction of travel to produce thrust. The engine has no moving parts other than the ions traveling in a vacuum line trapped inside electric and magnetic fields. So what is the size of the helical engine? According to New Scientist, the helical chamber would have to be pretty large, around 200 meters or 656 feet long and 12 meters or 40 feet in diameter to be precise. By comparison, Musk's Starship, the most powerful rocket, is 120 meters high and has a radius of 9 meters. And it would need to generate 165 megawatts of energy to produce 1 newton of thrust. That's the equivalent of a power station to produce the force required to accelerate a kilogram of mass per second squared. So a lot of input for a teeny tiny output. It is horribly inefficient. However, the helical engine will operate in a space without friction, so there is a high hope it will work. The engine can get close to 99% of the speed of light. The helical engine is far better than conventional rockets because it doesn't use any fuel. The Saturn V, for example, needed to burn about 20 kilograms of fuel for every 1 kilogram of payload just to reach the moon. And things get worse the farther you travel. If you wanted to send a probe to the nearest stars, you'd need about 2,000 kilograms of fuel for every kilogram of payload, and your trip would still take 100,000 years. Burns wants his idea to get critiqued or reviewed, after which he will decide what is next with his invention. Let's hear what you think of the helical engine in the comments section below.